Hello children. Now we have to study the last exercise and very important exercise, and the topic is multiplication of matrices. The last topic, multiplication of matrices. Now first is now the condition we have studied when you can add or subtract two matrices. Can you add any two matrices? Can you subtract any two matrices? No. There is a condition. We can add or subtract only those matrices which are having the same order. It means that was the compatibility, or that was the condition required for the addition and subtraction of the two matrices. Similarly, in the product also, in the product of two matrices or in the multiplication of two matrices, one condition is there, means when to multiply these two matrices. If the two matrices are given, you can multiply or not. It means we cannot multiply any two matrices. Some conditions are there, some restrictions are there. That is called compatibility of two matrices for multiplication. It means when you will say that the given two matrices are compatible for multiplication. So condition is, suppose order of first matrix is m by n and order of second matrix is p by q. Correct? Clear? Suppose if first matrix is of order m by n, second matrix is of order p by q, then when AB is possible, what is the condition? What is the condition when AB is possible? It means when AB is defined. That is called compatibility of multiplication of two matrices. It means two matrices are said to be compatible or conformable for the product or for multiplication if the condition is number of column of the first matrix. Number of column of the first matrix is equal to the number of row of the second matrix. This is the condition, this is the compatibility condition for the multiplication of two matrices. Clear? Whenever two matrices are given, then first we have to identify, first we have to check whether the condition or the compatibility is satisfied or not. And what is the compatibility condition? If AB is, we have to find AB. If AB is to be defined, the condition is number of columns in the first matrix must be equal to the number of rows in the second matrix. Correct? Number of column of the first matrix must be equal to the number of row of the second matrix. Then only product AB is defined or product AB is possible. Correct? Now the second thing, whenever you are adding or subtracting two matrices, after addition or subtraction we are getting a matrix. Correct? It means in total we are having three matrices, like A and B are the given matrices for addition or subtraction, and after addition or subtraction we are getting a third matrix, that is sum matrix or the difference matrix. And what is the order in the case of addition and subtraction? Throughout the order is same. It means for addition and subtraction, order of the two matrices must be same, and after adding or subtracting, whatever matrix we are getting, that is also of the same order as of the given matrices. But here the case is different. Here also we will be getting three matrices. Why? First matrix is A, second matrix is B. Then after multiplying both the matrices, if it is possible, if it is compatible, after multiplying the two matrices, we are getting another third matrix. And what is the order of the third matrix? And why it is needed? Since if you are not knowing the order of the matrix, how you will form the matrix? How will you calculate the matrix? Clear? How you will obtain the matrix? So the condition is, first, when AB is possible, when product of two matrices is possible, when number of column of first matrix is equal to number of row of second matrix, then the product or multiplication is possible. And after product, what is the order of the product matrix? order of the product matrix. That is here in this case, what is the product matrix? AB. Then what is the order of the product matrix AB? Simple. See, these two values are same. It means N and P both are same. Now N and P are same. Now these two numbers or these two elements are required only to check whether the matrices can be multiplied or not. These two numbers here, number of column in first matrix, number of row in second matrix. These two numbers are important only to check whether multiplication is possible or not. Now we have already checked multiplication. It means these two are done. What is left here? Here it is left M and here it is left Q. M is the number of row in first matrix. Q is the number of column in second matrix. It means what is left here? Two quantities for the checking. Two quantities were required for checking whether two matrices can be multiplied or not. Now two quantities are left. Which one? Number of row in first matrix and number of column in second matrix. Now this will give the order of the product matrix. It means what is the order of the product matrix AB? What is left? Here M is left. It means M pi. And here what is left? Q. It means this is the order of the product matrix. Correct? Now we will take some examples for understanding. Now we will take some examples. Suppose I am taking one matrix of the order 2 by 3 and second matrix of the order 2 by 2. Correct? I am having two matrices A and B. First order is 2 by 3, second order is 2 by 2. Now we have to check whether we can find AB, that is AB is possible or not. We have to check AB is possible or not. AB means what is the condition for multiplication of two matrices? Number of column in first matrix must be equal to number of row of the second matrix. Now what is the number of column in A? Number of column in A is 3. What is number of row in second matrix? That is 2. It means 3 is not equal to 2. Correct or not? Clear? It means here AB is not possible. Here AB is not possible. Why? AB means number of columns in A must be equal to number of row in B. But number of column in A is 3 and number of row in B is 2. It means matrix multiplication is not possible. Now check for BA, whether BA is possible or not. Again the same definition. BA means the first matrix is B and the second matrix is A. Now in first matrix, what is the number of column? First matrix is B, number of column is 2. Correct? First matrix is B and in first matrix we have to take number of column. Number of column is 2. Now in second matrix is A. Second matrix we have to check number of row. Second matrix, what is number of row? In second matrix number of row is 2. It means both are same. 2 and 2. It means BA is possible. Correct? It means BA is possible but AB is not possible. If confusion is there, you can write like this. First you will write B and then you will write A. Correct? Then you have to find BA. You will write the first matrix first, that is B, and the second matrix. Afterwards, then number of column in first matrix is equal to number of row in second matrix. And you can see both are same, 2 and 2. It means order of the first matrix is 2 by 3. Here it means BA is possible. Correct? Now when you will multiply BA, this will give also matrix. When you will multiply B and A, that is BA, B is also matrix. Then what is the order of the BA matrix? Already I have told these two quantities are for checking whether the BA matrix is possible or not. Now these two are done. Correct? Now what is left? What are the quantities left? Here number of row is left 2. Here number of column is left 3. It means what is the order of the BA matrix? 2 by 3. Correct? What is the order of the matrix? BA, that is 2 by 3. Understood? Now, one thing is left. How to obtain all the elements of the product matrix? Now, what we have studied, whenever two matrices are given, you can identify, you can check whether two matrices are compatible for multiplication, whether it is A into B or B into A. Clear? The concept is whatever it is given, suppose B into C is given. Then how B into C is possible? Suppose B into C is given. Suppose we have to check whether B into C matrix is possible or not. If you have to check B into C matrix is possible or not, what you have to do? The concept is same. Number of column in first matrix must be equal to number of row in second matrix. It means in first matrix we have to check number of column. Correct? In first matrix we have to check number of columns. First matrix we have to check number of columns. Correct? First matrix number of columns. Second matrix we have to check number of rows. Clear? Any XY, YZ, BC, CB, AB, DA. Correct? And after that, second thing, what is the order of the matrix after multiplication? So what is left? Like here, what is left? Number of row in first matrix will be left and number of column in second matrix will be left. That will give the order of the resultant matrix after multiplication, that is 2 by 3. Correct? Clear? Now we will discuss how to obtain each element of the matrix after multiplication. It means when we have multiplied both the matrices, if it is possible, then how to obtain the required matrix which is obtained after multiplication. It means after multiplication, how you will get each of the elements of the product matrix. Now we will take one example. Here I have taken two matrices. First one is matrix A, order is 2 by 2, you can see 2, 3, 4, 5. Second I have taken matrix B, order is 2 by 1, 2 rows and 1 columns. First we have to check whether AB is possible or not. Can we obtain AB? Then AB means we have to check number of column in matrix A must be equal to number of row in matrix B. Correct? Number of column in matrix A must be equal to number of row in matrix B. See, what is number of column in matrix A? That is 2. What is number of row in matrix B? That is 2. It means both are same. It means AB is possible. AB is defined. AB is possible. Correct? Why AB is possible? Since for AB to be defined, number of column in first matrix must be equal to number of row in second matrix, and we can see both are 2 and 2. Correct? Now, it means AB is defined. Correct? But what is the order of the matrix AB? What will be the order of the matrix AB? Already I told. These two quantities are done for the checking of the multiplication of the matrices. Now what is left here? 2. And what is left here? 1. It means what is the order of the matrix AB? Matrix AB is of the order 2 by 1. Understood how to find the order of the matrix after multiplication? That is the product matrix. Clear? What is left? Number of column, number of row. Compared. After that, what is left? Here is left number of row 2. Here what is left? Number of column, that is 1. It means what is the order of the product matrix? That is 2 by 1. It means AB is of the order 2 by 1. Now, if the matrix is of the order 2 by 1, then what is the structure of the matrix? Whether this kind of matrix or this kind of matrix. You can find easily. Why? Already this is 2 by 1. This is 1 by 2. But this is 2 by 1. It means now you are getting the importance of order of the matrix. It means if you are having the order of the matrix, we can find or we can recognize the structure of the matrix. Clear? It means AB is of the order 2 by 1. It means AB will be like this. That is A, B, X, Y, whatever. It means AB is of the order 2 by 1, and what is the structure? That is column matrix. Correct? Now, how to obtain the matrix AB? See, I am going to obtain matrix AB. It means AB will be, first you substitute the value. Matrix A is 2, 3, 4, 5. This is matrix A. Then substitute matrix B. Matrix B is 1. This is matrix B, correct. And how to find the required matrix? See, already we have done. AB is like this matrix, column matrix. AB will be of this structure. Now, how to obtain the elements? Whenever you have to multiply matrix, first you have to take the row and multiply into the column. What is the row? 2 and 3. And what is the column? 1 and 2. It means we have to multiply the corresponding elements of row to the corresponding elements of the column, and we have to add the elements to obtain the first element. It means, see, I am writing. I have taken first row, that is 2 and 3, and here I have to take first column. Now multiply the elements. 2 will be multiplied to 1, it means 2 into 1. Then we have to add, here we have taken R1, that is 2 and 3, and C1, that is 1 and 2. 2 is multiplied to 1, then we have to add plus. Second element will be multiplied to second element, that is 3 into 2. This will give one element of the product matrix. Understood? Whenever you have to multiply two matrices, take the first row and multiply the first row to the first column of the second matrix, and corresponding elements will be multiplied and added. That will give the single element. Correct? Now, row 1, column 1. Finish. No more columns are there. Now, we will take same procedure with row 2, that is R2. Now, second row will be multiplied to the first column in the same manner. Here, the first element is 4, and here, in the second row, what is the first element? 4. And here in the first column, what is the first element? Corresponding elements means row and columns will be changed, but corresponding elements means first element will be multiplied to the first element of both rows and columns. Second element of the row will be multiplied to the second element of the column. This is called corresponding. It means first element is 4, here first element is 1, it means 4 into 1. Then we have to add, already I have told. Then second element is 5, and here second element is 2. Means 5 into 2. Understood? First row, first column, corresponding elements 2 into 1 plus 3 into 2. Then second row, first column, corresponding elements multiplied and will be added. It means 4 into 1 plus 5 into 2. Now add, this will be giving finally 2 plus 6, that is 8, and 4 plus 10, that is 14. Correct? This is the required matrix AB. Understood little bit? It will be understood, don't worry. This is only the first question. Will be understood. Now, second question. I will take one more example, then we will proceed with the exercise. This time I will take two matrices of the same order, that is matrix A 3 minus 1 6 and matrix B 4 5 1 minus 2. Both are of the same order. Correct? Clear? Directly you can verify AB is possible or not. You will tell me. AB is possible. Why? Number of column in first matrix is equal to number of row in second matrix. Correct? AB is possible. And what is the order of the matrix AB? Matrix AB means which will be getting after multiplication. Order will be what is left. 2 by 2, it means what is the order of matrix AB? That is 2 by 2. Correct. Now how to obtain the matrix? Write the matrices A and B. A is 2, 3, minus 1, 6. B is 4, 5, 1, minus 2. Correct. Now, if matrix AB is 2 by 2, it means 2 by 2 matrix means AB will be like this. A, B, C, D. Correct or not? AB will be like this matrix A, B, C, D or not? Correct? Wait. AB will be like A, B, C, D. This will be matrix A or not? 2 rows, 2 columns. Why 2 by 2? Now how to obtain the elements? I have told. First we have to start with row and then we have to multiply by column. Take the first row, multiply into the first column. How to multiply? We have to take corresponding elements, will be multiplied and then added. Here I have taken R1 and I have taken C1. Multiply R1 and C1, it means multiply the corresponding element. First element is 2, here first element is 4, it means 2 into 4, and then we have to add, then 3 into 1, that is 3 into 1. This will give the first element. Correct? Now, again, second column is left, then we will take again R1 and multiply to the second column. First we have multiplied first row and first column elements, then again one more column is there, then it will be continued, repeated. First row elements again will be multiplied to the second column elements, corresponding elements. It means first will be multiplied to first, second will be multiplied to second. Now first is here 2 and here first is 5. It means, no, this will be giving second element. It means after some gap. This will give 2 into 5. That is 2 into 5. And then we have to add. Correct? Second element is 3 and here second element is minus 2. It means 3 into minus 2. Correct? Clear? First row, first column elements, multiply and add, that will give first element. This is first element. Then again first row and second column elements, multiply, this will give second element, multiply and add. Similarly, the process will be repeated for the second row. Again, second row will be multiplied to first column. Multiply minus 1 into 4. Then we have to add 6 into 1. This will be third element. Row wise I am taking. Then clear. Then second row, second column. Correct. Second row, first column, then second row, second column. This will be minus 1. Take the corresponding elements. First into first, second into second. It means minus 1 into 5. This will be 5 into minus 1. And then second element 6 into minus 2. It means plus 6 into minus 2. Why I have done this plus? I am taking plus since already I have told we have to multiply. First we have to take row of the first matrix and column of the second matrix. Row and column is multiplied, corresponding elements will be multiplied and added to obtain the single element. Correct? Now, what is the final matrix? Final matrix is correct. Final matrix is 4 into 2, 8 plus 3, that is 11. Correct. Next is 10 minus 6, that is 4. Next is minus 4 plus 6, that is 2. Minus 5 minus 12, that is minus 17. Correct. Minus 5 and minus 12, that is minus 17. You can see this is the required matrix AB. Now some more little bit understood. Now we will start with exercise, but in the next lecture. Clear? You will see the examples. we will start the exercise based on the product of the matrices. Very important exercise. At least one question is necessary in your board examination. One question is there. You can see your previous year papers. One question is already there in the paper based on product of the matrices, and the question is in two parts. First two matrices or three matrices are given. One matrix is unknown. Clear? Three matrices are given. One matrix is unknown. One matrix equation is given. First part, find the order of the matrix mx whatever, means unknown matrix. Clear? First part, find the order of the unknown matrix. Second part, find the matrix. Find the matrix means like this, we have find the matrix. Find the matrix means find each element of the matrix which is unknown. Clear?